Welcome, everyone. We're very excited to have you here at our second webinar of the summer from the PSEO Coalition called Using PSEO Data in Practice, Tools, Insights, and Key Considerations. I am Gina Johnson. I serve as the director of the PSEO Coalition. I am also principal and co-founder of Data Empowered Consulting. And I'm going to ask our host of today's webinar, Christopher Pena, if you could go to the next slide, please, and just introduce both of us, myself and Christopher Pena. And Christopher Pena has two roles, two hats. He's only going to wear one today, but he always is wearing the other one because you can't help yourself. We have many roles, and we try to bring those roles and our knowledge and experience of those roles here to the PSEO Coalition. So Christopher serves for the PSEO Coalition as our data literacy partner and our student intern supervisor, which is fantastic. We have student interns doing some wonderful stuff with the leadership of Christopher. And he is also assistant professor of the practice at the University of Denver, which is where he has this knowledge and this experience and makes him an excellent teacher, which for those of you who, if this is your first webinar with us, you're going to realize today. On the next slide, I just want to highlight that this is our second in a series of 3 summer webinars. So we started on June 26th, getting started with the PSEO Explorer. Those of you who missed that one, I'll be putting a link in the chat. You can always go back and watch it. We have a recording and also the slides of that on our website and our events page. This is, of course, the July 29th session, and we want to highlight the fact that, and we will have a QR code later on, and I'll provide a link as well in the chat where you can register for the August 28th, where we'll get even more advanced talking about APIs and data integration for deeper analysis. So if you don't feel like you had enough PSEO, and we hope that you haven't, by the end of this webinar, you'll be able to join us again on the 28th of August. And Christopher will be focusing on some other things there. I'm just going to mention a couple housekeeping, as everybody does on every webinar. Recording and slides, as I said, are available from the first one. They'll be available from this one as well. I'll be putting that in the chat in a moment. I want to highlight the fact that during this webinar, please keep yourself on mute at this point. And if you have questions, we hope that you do. Please use the chat. So we don't have a separate Q&A. We're just using the chat. We want this to be relatively informal. So as questions come up in your mind as Christopher is presenting, please include those in the chat. I am going to put myself on mute when I turn it over to Christopher, and it's going to be my job when Christopher pauses a few times during this webinar to feed some of those questions to him. I will also, if there are some questions that I know the answer to in terms of related to the PSEO data and pieces like that, I can certainly answer those in the chat as we go as well. So please do use the chat function to share those questions, and do it just as we're going, because we will pause at points and answer those questions. So with that, I'm going to turn it over to Christopher, and welcome everyone. We're very excited to have you here.
Well, thank you, Gina, for that kind introduction, and welcome everyone to our webinar. As Gina mentioned, this is our second in a 3-part series. So our main goal is to help you understand more about the PSEO data and how it might help you in your own research and analysis. Today, we're going to focus primarily on PSEO data in practice, so some practical implications that come along with using the data set, especially outside of the PSEO Explorer. Hopefully, coming in today, you have a little bit of familiarity with the PSEO Explorer as a tool. If you're still getting to know it, that's okay. We're going to cover some basics in addition to more technical topics today. And then, as Gina said, we'll cover some more advanced topics in our next webinar. Plan for today is to very briefly touch on the PSEO data in context, so how it sits in the larger landscape of data at the federal level. Then we'll talk about how we can actually access the data from the PSEO Explorer website. We'll talk a little bit about how to prepare our data, pre-processing, getting it ready for research and analysis. Then I'll share with you some general and technical considerations that you might want to keep in mind as you're working with those data files. And then finally, at the end, we should have some time for questions and discussion. And as Gina mentioned, I'll pause at a couple of points along the way so that we can answer a few questions relative to the content that I'm sharing with you at that point in time. My hope for you today in this webinar is to really develop a deeper understanding of some of the technical considerations that go along with the PSEO dataset, how it differs from other data sets that you might be familiar with, some of the nuances that come along with this particular data set, and especially how you could use it in partnership with some external analysis tools like Python, Tableau, Power BI, things that we all commonly use in our work and practice. And all of that is ultimately to help us to use the data set with confidence and to use it responsibly for the work of research and analysis. So let's start by talking about PSEO data in context, how it sits in the national landscape of data that we have available. Many of us come from an IR and IE background. I myself worked in institutional research for about 12 years. And so these data sources that you see here are probably familiar to you. And I wanted to highlight how the PSEO data differ from these data sets and how it actually gives us some additional information before we move on to more technical content. So you're probably familiar with the college scorecard coming out of the Department of Education, and that gives us a couple of data points like median earnings for our graduates, and also what percentage of graduates are earning more than high school graduates. Now, the downside to the college scorecard is it's more limited to students who are receiving federal financial aid, so it's a smaller scope of data than we have with our PSEO data set, which is all the graduates for which we have data available. You might also be familiar with some of the reports and studies that come out of the National Center for Education Statistics, or NCES. For example, annual earnings by educational attainment. So we can look at earnings by degree level, essentially. Now, these are really great and robust studies. They tend to be a little bit lagging in terms of how long it takes to get them out to us, because of course, studies like that do take a while to perform, but they give us some very valuable information. But again, it's often limited to students who are receiving federal financial aid. And of course, with data sources that come from the Department of Education, we just have to be mindful, given the current administration, that some of this work might be scaled back at some point in the future. So we do have to keep that in mind. Another data source that we have is the US Census Bureau. And you're probably familiar with the American Community Survey. That gives us some information about the people in the United States and things like, what is the median earnings by educational attainment? So thinking about, for example, in a particular state, what is the median earnings for someone who received a bachelor's degree or just a high school diploma? We can also look at that crossed with things like geography, so again, by state, and then we can also cross it with demographic categories like gender and race and ethnicity and age group. So it gives us a fairly robust picture of what's happening with our graduates. Now, all of this does give us a good picture of what's happening with post-secondary graduates, but the PSEO data give us a little bit more nuance. So think about points in time. PSEO data gives us 1, 5, and 10 years after graduation. For earnings, we also get quartiles, the full set of quartiles, 25th, 50th, and 75th percentiles, whereas these other data sources just give us the median earnings. So while they are helpful, the PSEO data really give us a bump up in terms of the amount of detail that we get about our graduates. So with that in mind, let's talk about how we can actually get the data to work with. Now, most of you are probably familiar with the PSEO Explorer, and that's what's shown here on this slide. And you can work with the PSEO Explorer as an interactive tool to get the data that you want to see. But what if you want to actually take the data out of the PSEO Explorer to do your own analysis? And you can do that in a couple of ways. On this slide, what you can see in the upper right is a link to download data. So what you're going to do is go to the PSEO Explorer website. On the left-hand side, you'll select a state of interest. I've got Colorado selected here. And then you'll click that download data link in the upper right-hand corner, and that'll give you an Excel file that includes 2 sheets, one for the earnings data and one for the flows data. So you'll get all the data that you're seeing on the page for the PSEO Explorer, but in an Excel spreadsheet. Very, very simple to do. Now, doing this has several key advantages and disadvantages, so it's important to keep that in mind as you think about, is this the right way to get the data? By far, I think the most important advantage is that the raw data here include the qualitative labels. So if you think about degree codes, for example, or SIB codes, program of study codes, we get the labels that go along with it. That's already baked into it. So we don't have to do any work to get that information. And because you're downloading the data state by state, the data are limited to one single state in a single Excel file, the file size itself is a little bit smaller, which makes it easier to work with. And that data file includes two separate sheets, one for the earnings data and one for the flows data. So from a data management perspective, if you like to have a single location for those data, that works really well for that. Now, there are some trade-offs here. If you want to do a national analysis, so all institutions in the United States that are participating in the coalition, or if you want to look at a small set of states, you would have to download multiple files and then bring them together in your own analysis platform. That could take a little bit of time, but of course you can also automate that process, and I'll talk about that a little bit later. Another consideration is that that file, the Excel file, includes some kinds of formatting. So there are headers, for example, that have colors and borders. That adds to the size of the file a little bit. There are also carriage returns inside some of the qualitative labels that break the words across different rows. I'll talk more about that a little bit later and how to handle that, but that may be a consideration that you want to keep in mind as you're working with the Excel data. So that's one way you can download the data. The other way you can do that is with a CSV file. CSV stands for comma separate value, and that is a way for us to include the data in a portable text file. The way it's set up is we still have rows and columns of data, but the columns are separated by a comma, and that's the comma separate value file. To get here, you go to the PSEO Explorer, and then in the upper right-hand corner, next to download data, there's a link to help. That's going to take you to this page that you see here, which is the homepage for the Longitudinal Employer Household Dynamics Study. This is the core data piece where our PSEO data come from. So this actually has a lot of documentation about the survey that provides the data. But in addition to that, it also allows us to download the data as a CSV file. To do that, you're going to go to this page, and on the top, on the left-hand side, there's a section for download public use data. That's where that arrow is pointing to. There's a drop down below that that allows you to select either all states, or you can narrow down to a particular state, and then the table below that will modify accordingly to show you the data files that you can download. What we have here is all data files for all institutions in the United States that are participating in the PSEO Coalition. At the top, you have a list of all institutions if you want to see who's part of the coalition. And then you'll notice that there are two files, PSEOE, which is the earnings data, and PSEOF, which is the flows data. Now, those are both saved as a GZ file, .gz, which is a compressed file format. It's kind of similar to a zip file. Now, if you have Windows 11 or Mac OS, you should be able to unzip that pretty easily. If you have Windows 10 or another operating system, you may need to download a third-party software to do that. So just keep that in mind as you're working with the data. Now, just like with the Excel file, there are some pros and cons that come with using the CSV file. One of the advantages of the CSV file is that you can get the data for all of the participating institutions in the coalition in one single file instead of having to download it state by state. It also includes some additional aggregations that you don't get in the Excel file. The reason for this is Excel has file size limitations and row limitations. So the US Census Bureau that prepares these data couldn't include all of the aggregations in that Excel file. With the CSV, you get all of those intersections that are possible. You also get two separate files, one for earnings and one for flows. So kind of back to my point earlier, from a data management perspective, maybe it works better for you to have them separated out. Some people like to keep their data a little bit more modular. So that's one advantage. Now, a main disadvantage is that the CSV file does not include qualitative labels for those codes. So think about the degree level, for example. You want to translate that into baccalaureate or master's. You're not going to get that information in the CSV file. I'm going to talk a little bit later about how to add that in, and we can do that through automation, but it's an important consideration to keep in mind. The file size for the CSV file is also larger if you get the one for the national data set. And that's going to be because we have more data for more institutions. So you want to keep that in mind as well as you're working with that file. Now, of course, you can download these files manually. You can go to the website and you can click on the links, and that's one way to do it. But I would also highly recommend that you try to automate the process. What you see here is a sample of a script in Python that our interns worked on earlier this year. And this allows you to actually download those .gz files, unzip them, extract the internal CSV files, and then get rid of the GZ compressed file. So it's automating that process pretty quickly. Now, of course, this presumes some knowledge of Python. And if you're still learning that as a scripting language, you can always use generative AI to really help you out. This is a great advantage of those tools that we have available today. In fact, if you type in a prompt well-structured to tell it exactly what you want to do, it can actually do a lot of the work for you. So I would encourage you to think about the resources that you have available to use your time and your staffing as efficiently as possible. Now, you have these two options, CSV and Excel, and which one do you use? So there are a few key questions I'd recommend you consider in evaluating that choice. First up, what is the scope of data that you plan to use? Do you just need a single state, or are you looking at several states or the national data set? That'll help point you in the right direction. Where do you want to do your calculations and transformations? Chances are you'll want to modify the data a little bit. Do you want to do that in Python, in Excel? Where do you feel most comfortable? How much time do you have to work on the data? If you need a quick turnaround time, the Excel data might work well because you've already got the labels built in. If you have a little bit more time and more staffing to deal with this, then maybe you use the CSV file and do some more advanced work outside of the PSEO Explorer. You also want to think about what tools you're going to use and what your level of expertise with them is. You can be ambitious, but you also want to be practical about what's available and what you can use with the data. So with that in mind, let's talk briefly about how we can prepare the data once we've actually gotten it. Most of us who work in the world of data and data management know that one of the first things we do when we're working with a new data set is to look for documentation. We want to understand the data, profile it to our best ability so that we can use it efficiently. If you go to that LEHD page that I pointed you to earlier, which is where you can download the CSV files, on the right-hand side shown here, there's a section for PSEO help. And there are a few different pieces there that are important to know about. The first link for PSEO methodology gives you some in-depth information about how the PSEO data are put together. So if you really want to understand where the data come from, some of the choices that census made, that's where you can go. But the main source that I would point you to is the PSEO data schema. That's the third link there. And that's going to give you really solid documentation about all of the elements inside the PSEO dataset. This is an example of what that documentation looks like. This is for zip codes, the classification of instructional programs, which we use for program of study. You'll notice that there's a CSV file listed there. That's going to give you the codes and the labels that go along with it. Then they usually have a little bit of information about where the data came from. And then we have a sample of the data inside that file. So you can see, for example, most of you are probably familiar, the zip code 01 corresponds to an agricultural field. And then the zip code at the 4-digit level, 01.00, is for agriculture general. So you could pair this with the CSV file to bring the labels into your CSV format. Now, one thing to keep in mind about the PSEO data is that it uses a wide format or a flat file format where the measures are captured as columns instead of as rows. And this is very important when you import the data into additional tools like Tableau and Power BI. So it does work to our advantage having those measures as columns because it makes math really easy to do. For example, in the flows data, there's a column that tells you the percent or the number of students who are employed at 1 year after graduation. Right next to that, there's a column that tells you what is the number of students in that group that are still employed in that state of the institution. All you have to do is divide those out as a ratio, and that would tell you the percent of students working in state after graduation at 1 year. And you can do that for any of the columns that you have there. This also makes merging data much more simplified. So if you imagine that you have two files with a flat format and you have a join column between them, something they share in common, then it's really easy to merge those data together. One disadvantage, although I wouldn't say it's a significant one, is that some of your analysis tools like Tableau and Power BI do prefer tall formats where you have your measures as rows. That typically works well when you want to aggregate or summarize across your records instead of left to right. So just something to keep in mind there. Now, I mentioned earlier that the CSV file doesn't have the qualitative labels that go along with the codes in the underlying data set. There are actually about 9 fields where you would need to add the labels in if you wanted to use the CSV file. Now, you probably want the labels to drop into an analysis or visualization tool, and so you can add those very easily. On the right-hand side, I have a sample for the degree level codes. And what you could do is download the CSV file with the codes and labels, and then merge that with the CSV file using the degree level as a join field. So again, you have access to all of those lookup values with the qualitative labels. If you want to bring data sources together, and we'll talk more about this in our next webinar in August, you can actually do that very easily with the PSEO data, whether it's the Excel file or the CSV file. So just a few options here. There are different ways to tackle this. In Excel, you can use XLOOKUP or VLOOKUP or index plus match to join the data together if you have them in spreadsheets. In Python, you could read the data into a data frame and merge them together using the pandas library. In Tableau and Power BI, you can use their built-in options at the start of a build process to merge your data sources together in a workflow. So very easy to work with these data, but again, we'll talk more about that in our next webinar. Now, I mentioned earlier that I would recommend that you consider automation as you're thinking about this process. And that's just to make sure that you minimize the amount of work time spent on preparing your data file. A few recommendations I would put out there for you. Consider the scope of the file you're creating. Is it a state level or is it a national level? That would help you out to figure out how much work you should put into that. I would recommend that you look at the file and then drop any columns that you're not planning to use. That'll make your file size a bit smaller, and you could write it out to a CSV file to minimize the file size as well. That being said, these files can get quite large, so just be mindful of memory limitations on your computer. It might be a little bit challenging to hold those data in memory. If you're merging data sources, I would highly recommend that you use a left join. If you're familiar with database design theory, a left join holds on to the data on our left side and then returns data from the right where it's applicable. So we always keep our base data like the PSEO core data set. I'd also recommend you keep the naming conventions in place for consistency and to facilitate joins, especially if you're planning to update the data periodically. When you join data together, you might end up with two columns that have the same data. That's the join field. And so as you're thinking about your process, you might want to remove one of them so you don't have duplication. And then finally, a very important thing to keep in mind, there are some data in the PSEO data set that are actually strings, but they look like numbers. So when you read it into Excel or Python, it treats them as numbers, but you actually want them to be treated as strings. For example, the institution code, which is the OPEID number, that's a federal financial aid number. We want to keep that as a string because it has leading zeros in it. Same thing with the zip code. Again, you're probably familiar with those. So we have like 01, 03, 09, and we want to make sure that those are preserved as well. And then finally, we also have the degree level, which is a 2-digit character with a leading zero as well for some of those codes. So before we move on, Gina, do we have any questions that popped up in the chat that we'd like to address now?
Yeah, thanks, Christopher. One thing I'm going to say before I pose the question from the chat is just to reinforce Christopher's comments about automation. I think one thing that maybe we haven't clarified or stated outright is that these data are updated by the US Census twice per year. So if you're doing analyses, to Christopher's point, that you know you're going to redo when there are new data, because these data do change, and we have lots of states, lots of entities that are joining the PSEO Coalition, and so each time these are updated, not only are there potentially new years of data, but there's also new institutions. So if you're looking at it nationally, the data set changes twice per year. So I just wanted to reinforce that piece. I'm not sure that we called out the fact that it is updated twice per year by the US Census. This next question, before I share it with you, Christopher, I just want to acknowledge to the group that neither Christopher nor I work for the US Census. And so while we partner very closely with our colleagues there, there may be some questions that we don't know the answer to. And so I'm going to pose this one to you, Christopher. If it's more of a census question, I'm actually going to put in the chat an email address that you can use. And our colleague Cody is on the other side of that email, and he really likes to answer questions. So I can reinforce that. But the question, Christopher, is could you address the processing the census does to address small cell sizes? And the comment, I noticed that when I sum across all institutions in a state and compare with the aggregated numbers provided in the data set, the numbers are close but do not match exactly. And the question is that due to the processing census does to ensure data confidentiality?
Well, that's a great question. Definitely something you want to consider as you're evaluating and profiling the data set. To the best of my knowledge, there is some pre-processing that handles data suppression for privacy purposes. So I believe the cell size is 30 or greater. And if the numbers are smaller than that, you won't see the data in the cell. It would just be null or empty. So that's something to keep in mind as well. I believe they look at the intersections of different data. They look at the noise in the data. They do a little bit of statistical processing. Again, that'd be a census question. But they do that ultimately to give us a clean and reliable data set where we're not concerned about the privacy or the identification of specific individuals within the data set. And if you want to know more about that, again, if you go to the LEHD methodology page, they have really great information about some of those choices that they've made and the rationale behind it.
Thanks, Christopher. And that concludes the questions at this time. So I'm going to let Christopher go forward and remind everyone, please do put any questions you have in the chat, and we'll answer those on the next pause.
Great, thank you. Let's talk through some general and technical considerations that you want to keep in mind as you're working with either the Excel or CSV file. One thing to know about the PSEO data as a whole is that they use a cohort model, and this starts to get at the question we just had about cell sizes. The data at the microdata level, the individual student level, are aggregated into cohorts based on degree level. So there's 3 levels that we have to work with. There's the all cohorts level, which includes all students in that particular intersection of filters. There's the baccalaureate degree levels, which are 3-year cohorts, and then all other degree levels are 5-year cohorts. So for example, if we have a 3-year cohort and it starts in 2019, it would be 2019, 2020, and 2021 graduates in that cohort. And then, of course, the post-graduation outcomes would be relative to the student's graduation date. So usually it starts the calendar year following the graduation point. This is really important to keep in mind because the data set itself includes pre-aggregated data. So for example, the all cohorts level is itself an aggregation that appears as a row in the data set. If you're bringing in the lower level of information, you would want to make sure that you exclude those pre-aggregated rows, because if you included them in your aggregation or summarization, it would skew your data or your findings. So something to keep in mind there as well. And this is a sample of some of the aggregations that we have available. If you go to the data schema documentation, you can actually find this under PSEO aggregations. And you can see there are many, many different combinations of filters that give us these pre-aggregated numbers. So the very first one, as an example, degree level by state of institution. What that means is that for a given state, so let's say Colorado, we would have institutions in Colorado, and that would be crossed with the degree levels. So baccalaureate, master's, doctoral, and so on. But again, we have lots of different intersections here. To the point in the question that we heard earlier, in terms of the numbers not quite matching, I've had that experience too. What I strongly recommend is play with the data and double check your work. That's a great approach. So I appreciate hearing our attendee talking about that. That's one way to think through, are my filters perfectly mirroring what I see in the PSEO Explorer? And if they're not quite the same, you might end up with slightly different numbers. So just something to keep in mind as you're trying to replicate what you see in the Explorer. In terms of columns, we do also have aggregations within those filters, the ones that you see on the left of the PSEO Explorer. For example, for institutions, we have all institutions in a given state. And then for the zip code, we have all instructional programs that rolls up the data at the lower level of information. And we have that for the ones that are shown here, so several different levels to work with. Now let's talk about some more specific technical considerations, and then we'll pause again for some questions. I mentioned earlier that in the raw data, in the qualitative labels, we have carriage returns. Those of us who are old enough to remember typewriters, you click the enter button on your keyboard, and that returns it to the next level. And so those are baked into some of these fields. They're actually coded in as /r/n. If you're familiar with Python or other scripting languages, that's how it's coded. The great news is if you don't want those carriage returns, it's actually pretty easy to get rid of them. In Excel, you could use the clean function. You do clean and then the cell reference. You can also do find and replace and look for the character type of the carriage return. In Python, you could use the string.replace method, so attach that to a data frame column and then define how you want to strip out specific characters. In Tableau, you can use a calculated field using the replace function. And then in Power BI, you can do something similar using DAX using the substitute function. So very different ways for each of the tool to handle those carriage returns and strip them out. And you might be wondering, well, why does that matter to me? It may not. For some of you, the labeling may be perfect for what you want to accomplish. In other cases, you may want a label to appear on one single line instead of broken across multiple lines. Think about the zip code, for example. The zip code labels tend to be very long at the 4 and 6 digit level. And so you may want to see that on one single line if you have a table with lots of rows of data. Personal choice, of course, in what you're trying to accomplish with your data. Now, the graduation cohort label is a little bit different. The other ones have lookup tables, those CSV files with a list of codes and descriptions, but there isn't one for the cohort, the graduation cohort. The good news is it's actually pretty easy to get the label that goes along with it. First off, you need to know that there's a graduation cohort column that has the start year for the cohort. I mentioned that example of 2019 earlier, so that's the start year. Then you need to know the number of years in that particular cohort. There's another column called grad cohort years that gives you that number, 3 or 5 years. Then mathematically, what you would do is take the start year, add to that the number of cohort years, and subtract 1. And that gives you the start year and the end year. What I'm showing here is a Python snippet that does exactly that. Now, it starts by checking for the cohort code, and if it's 0000, which is read in as 0, then we return all cohorts. That's the code for all cohorts. And then else, in all other conditions, we're going to do that math that I just walked you through. So that's one way you can easily derive the cohort code with that. So one thing that I would ask you to keep in mind as you're thinking about those values is because we want to do math on the cohort years, you want to read the data in as a number, even though we typically think about things like years and date components as string values. So just keep in mind, if you're going to do math, you want to make sure you read in those data as numbers. We'll touch on this a little bit more in our next webinar, but more than likely, you'll want to bring together different data sources around institutions. So you have information aggregations for a given institution, you have some external data, maybe internal to your organization or university that you want to merge together. How can you do that? Well, inside the PSEO data, we have the OPEID number, which is the federal financial aid number for specific institutions. Now, there are about 900 specific institutions in the PSEO data set, and out of them, only about 63 do not appear in the IPEDS universe. Those are typically vocational schools or other institutions that aren't receiving financial aid from the federal government, so they're not required to submit IPEDS surveys. The IPEDS surveys give you the OPEID in the institutional characteristics survey. So if you want to merge the data together, you could use the OPEID, except for that small number of schools that don't exist in IPEDS. There are also other ways that you can join data together. A logical choice would be the name of the school or institution. The challenge here is that the names between the PSEO dataset and IPEDS are not always perfectly the same. So what you see here is a few examples of schools that we as humans with our eyes can tell they're the same schools, but from a data perspective, they are slightly different. For example, University of Arizona on the PSEO side has the word "the" in parentheses, and then on the IPED side, it's just University of Arizona. So you'd have to do either some visual checks or some fuzzy matching in your coding language to get those to line up with each other. You might also want to think about geography. So imagine that you want to know the state that goes along with a particular institution. The great news is if you do the CSV file and you combine that with the label file for institutions, you'll get the institution state code. And that's listed here in the metadata on the right-hand side. The challenge is there are aggregation levels for institutions in a particular state, like institutions in Colorado. In that case, in the label institution CSV file, there is no institution state code. So I would expect to see CO for Colorado, but it doesn't exist there. The good news is there's another companion column, the state FIPS code, which is a federal classification of geographic regions. We do have that for the institutions in a particular state record. So what you can do is create a dictionary or a file base that has your state codes, your state names, and your FIPS code. join that to the label file with the FIPS code as the join column, and then you could get access to the additional information for geography. This is especially important when you want to use the state as a filter or a grouping variable, especially in tools like Tableau or Power BI. And finally, with geography in mind, you're probably going to want to take a look at the geography flows information and visualize it as a map or something similar to that. One thing to know about the geography data is there's a geography code inside the flows data, which is comparable to the US Census Bureau's division data. So for example, in the PSEO geography data, the movement of graduates after graduation is shown by census region, like the Northeast, for example. There are 9 census regions. So you could use geography equals division to get alignment between those data files. And the data from the geography information outside of PSEO are often available as shape files. Those are .shp files that you can find widely publicly. The federal government through Tiger typically has those available for public use. So you can download those and they integrate really well with tools like Power BI and Tableau. That being said, if you are using those tools, you might consider, does your institution have access to an Esri or ArcGIS server? Those are engines that allow you to do more robust geographic analysis. You also want to think about Power BI. You may need to use a specialized JSON file format in order to work effectively inside of that tool. But both of them work very well and very friendly with geographic information from those shape files. All right, that is everything that I wanted to share with you today. What you see up here is a QR code for our next webinar. So while we're starting to work on questions, if you're interested, please take a moment to register for the next webinar, and I'll bump it back to Gina to see what questions we have.
Thank you, Christopher. I want to do a thank you to Fred Church, who provided some extra information in the chat. Thanks for that, Fred. Some information to answer someone else's question. I'm currently answering a question related to Credential Engine and their methodology, and also the Workforce Pal piece, and I will answer that in the directly in the chat rather than calling that one out. One very specific question, do you have the link available to the shape file you referenced for geography?
I don't have it with me right now, but I do have that to share out. So Gina and I were chatting about additional resources that we'll share after this webinar. For example, I showed you some examples of a script that we use to automate the download and preparation process. We'll share that out so you don't have to redo all that work that the interns have already spent some time working on. And then we'll have some links to some of the materials like the metadata and the download of the lookup files. And we can also include a link to the shape files so you don't have to go searching for that. So we'll include that with the follow-up materials.
Thank you. That's exactly, just to call out exactly why we want to open up this community of researchers and learners, is so that everybody doesn't have to recreate all of this stuff themselves. So appreciate the work that you and the interns are doing there, Christopher. Calling out, there isn't another question in the chat, but because we are a small enough group and because we intentionally are using Zoom meeting rather than Zoom webinar for this, and so you are available or able to unmute yourself. If anyone wants to use the raise hand function and ask a question directly, you're welcome to do that at this time, because I know sometimes typing a question in chat and formulating it in a sentence or two in a small box is more challenging than calling it out verbally. So I'm going to pause in true teacher fashion for, for a moment to see if anyone wants to do that. Do please use the raise hand function in Zoom. And while we're waiting on that, Christopher, I'm going to, if you can open up the chat rather than me reading this next question, it's if you want to go ahead and read it. And Emily, if you're not able to go off mute, totally understand, and we will answer it based on what you typed in. But if you are able to go off mute and would like to ask this question verbally, do feel free to do so. Now
Thank
give
you for
Chris.
pointing me to that. I'm just reading the question real quick.
Yep.
Let's see. Yes, so I'm going to have to put on my old school IR hat if I remember correctly. So if I got this wrong, please correct me. I believe that the number of graduates is based on not the calendar year, but typically July 1st to June 30th as a cycle. And so that number of graduates will be different from the PSEO data set, which again is based on the data are going to start the next calendar year after that particular student's graduation point. So 1 year after they graduate is the next calendar year. This is also going to be based on the students where there's a match in the unemployment insurance information. And then also, in addition to that, there's some parameters that census puts on who's included within that subgroup. For example, if someone is underemployed, and what I mean by that is they're part-time or seasonal in such a way that they don't have stable full-time employment throughout the year, they might be excluded from the PSEO data. So I think that's a great question. You'll see some differences there. It's a great way to ballpark how they align with each other, but I don't think they'll ever be perfectly in alignment.
Thanks for that question and response to you, Christopher.
Mhm.
One thing, I did answer the question in the chat, but I just want to bring it up. It was more of a less of a technical specific question and more about kind of what's coming next for PSEO, Christopher, which is why I answered it in the chat. But there's a really good question in there about how we might use the system for short-term programs that will access Workforce Pell next year. And just a little look under the hood of the process for PSEO. This is still considered an experimental project with Census. They have a small amount of resources that they devote to this. We massively appreciate that, and I wouldn't call it small because of the, what it does for us and the amazing opportunities we have of this data set. But by their standards, by the massive, census and how many staff they have, it is still considered an experimental project and a small project at that. And so I say that to explain why we don't have really quick changes to PSEO. So while things are happening, like Workforce Pell is something that's new and it's something that they're thinking about. We are in conversation, and that's the members of the PSEO Coalition, which would be the entities that share the data directly with Census to provide this data set, are in conversation about these and thinking about it. Also, understanding that any movement and any changes to the data set, to the Explorer tool, and all of the files that go along with it are things that do not happen very swiftly. So right now we have the degree files, as Christopher was talking about, or the degree levels, excuse me, within the data files go from certificate up to doctoral. But we don't, other than sort of a short-term certificate, we don't have any programs that are shorter than that. We don't have any what some term non-degree or non-credit kinds of programs in these data files. There's conversations about it potentially in the future, but even PSEO 2.0 is expected by January 2027, and that won't have those changes. That one is going to have a connection to IRS data, which is going to expand our understanding and expand our earnings data capacity, which is exciting. But everything moves relatively slowly in a process. So any other questions, either folks who want to type it in the chat or who want to go off mute and ask a question of Christopher at this time?
And Gina, while we're waiting for hopefully some hands to pop up, and again, please feel free to ask questions. I'll do my best to support you as I can. I just wanted to highlight a note from the chat from Andrew, one of our partners at Census, that the data suppression that we were talking about earlier is for accuracy, not privacy. So thank you for that clarification. I'm still learning about the data set, of course. And that kind of information is what I was referencing on the metadata page. They do a great job of outlining some of these decisions and the rationale and the approaches. So I would definitely point you towards that as a resource if you have those deeper questions.
Excellent. Well, I'm going to, since there aren't any other questions at this point in time, I just want to say thank you to everyone before I turn it over to Christopher for a last statement here. Thank you to everyone for engaging with us, for your interest in these data. We are expanding tools, including these webinars, including our resource library, which is on the PSEO Coalition website, which I will put in the chat. And we want to encourage you all to attend the August webinar. If you aren't already registered, please do so. The recordings for this one, it will be about a week while we process it and work with our web design team to get this one and the files that Christopher mentioned, as well as the slide set, up onto our events webpage, but expect that to be up there next week, as well as the one from the first webinar. And we're just very grateful for your interest in these data, and please stay engaged with us. And turn it back to Christopher if there's any last statement that you wanted to make as the host of this webinar.
Well, thank you. Thank you for the opportunity to share this information with you. As Gina and I have talked over the last year, working around the data and working with our student interns, there have been a lot of lessons learned in terms of how the data work, how we can work with it in external tools like Tableau, Power BI, and Python. And I'd really just encourage all of you to explore the data and the possibilities. Even if your technical skills are still growing, if you see Python and you think, gosh, I can't do that, I'd rather do it in Excel, there's always a way that you can work with the data with the tools that you know and feel comfortable with. I think you all see the potential of these data to help us understand what's happening with our students after they leave us. And of course, we want to support their success and be able to tell their story. And this is a great data source to do that. So full credit to our partners at US Census. And thank you to the PSEO Coalition for bringing together this community of practitioners to really think about how we can better tell this story through our data. So thank you again for your time today, and I appreciate the opportunity to be with you.
Thanks for hosting us, Christopher. Bye, everyone.